Welcome to the Automation World Get Your Questions Answered podcast, where we connect with industry experts to get the answers you need about industrial automation technologies. I'm David Greenfield, editor-in-chief at Automation World, and the issue we'll be looking at in this episode is developing an MES and an industrial Internet of Things data platform strategy. And joining me to discuss this is Francisco Almada Lobo, CEO of Critical Manufacturing, a supplier of manufacturing execution system and smart factory software for IoT data platforms, augmented reality, digital twins, and advanced planning and scheduling. So thanks for joining me today, Francisco.
Thank you, David. It's a pleasure being here.
So, first, let's make sure our audience understands both manufacturing execution system or MES technology as well as IoT data platforms. So let's start with MES, and can you give us a brief overview of what MES software is and how it's used to optimize manufacturing operations?
Oh, thank you. It's a great start to start with the basics and the definitions. So a manufacturing execution system, or an MES, is a little bit like an ERP, just focused entirely on what happens inside the factory. So while an ERP system handles business-wide planning and finance and things like that, MES manages the execution of production in real time. So it basically tracks and controls orders, lots, batches, products, routes, material flows, and equipment on the shop floor. So an MES connects machines, connects people and processes to give manufacturers visibility and control over production, ensuring, of course, that the operations are efficient, consistent, and responsive. And so there's many benefits of applying a manufacturing execution system, typically split in three areas. One is productivity through real-time monitoring, improved scheduling and resource utilization, faster issue resolution, and so on. Second is quality or regulatory compliance to enforce processes, to provide the traceability of materials and operations, and so on. And third, which is flexibility and innovation, accelerating introduction of new products and new processes, supporting more agile production models, and essentially, seizing windows of opportunity. And so, in short, MES is a little bit like a digital backbone of the modern factory, bridging the gap between high-level planning and hands-on execution to drive smarter and more agile manufacturing.
So then, what is an IoT data platform, and how is it used in a manufacturing environment?
Okay, I would like to start by saying, I prefer the term industrial data platform rather than IoT because it creates some problems, and I'll explain you why. So these platforms do much more than just collect data from machines and sensors. So the idea is that they also ingest data from enterprise systems like MES or ERP, quality management systems, and others. And so it's the combination and contextualization of all this data, both from the operational technology and information technology, what we call the OT and IT, that really creates value. So in a manufacturing environment, the data platform acts like a unified layer that collects, stores, and structures data from across the operation. It enables real-time monitoring, advanced analytics, machine learning, for instance, by bringing together raw sensor data with context that comes from the production orders, the quality records, or the maintenance logs and supply chain systems. And so, there's many different use cases. Predictive maintenance is one which is often referred, process optimization, quality improvement, and so on. And so by unifying diverse data sources, this industrial data platform becomes really a powerful enabler of a digital transformation and helps manufacturers make essentially faster decisions, smarter and more predictive ones across the entire enterprise.
And you explained this, my next question that I have for you, you explained it a bit in your explanation of the industrial data platforms, but can you describe a little more how MES and the industrial data platforms complement each other in terms of connectivity and access to real-time data?
Yeah, very good. So, what I say in Digital Factory, it's no longer just about MES or IoT data platforms in isolation. So, what we're seeing and we are really advocating for is that what we're seeing now is an emergence of a three-part foundation for Industry 4.0 success, which is MES, equipment connectivity, and data platform. And each plays a really distinct but interconnected role. So the MES manages the execution. Um, the equipment integration enables the real-time communication between the MES and machines, and the data platform ingests high volumes of data from equipment and systems, contextualizes and stores this into a unified model that later allows analysis and machines to be done. But the point is that these trio together, it's only when the three of them are working together that we can create real value. That's when equipment and sensor level is not only captured, but it's also contextualized with MES information stored in a common data model, and enables advanced analytics, traceability, and AI-driven decisions at scale, and actually closes the loop because the actions that will come out of this, the decisions, the suggestions, will actually be bridged back into the MES, the IoT, and the equipment itself. Right, so the value lies really in this combination, and this is a shift that we're seeing for some time, and now it's obviously clear that this is the path forward in terms of Industry 4.0.
Well, thank you for explaining that, Francisco. I wanted to make sure our audience was really clear since the amount of overlap and connectivity between the two systems that's necessary for this. So, considering, the vast amounts of data that are generated by connected devices in a manufacturing environment, how do MES and industrial data platforms handle all of this data effectively?
Yeah, it's really true that a modern factory generates massive amounts of data from machines, sensors, from systems, and both MES and data platforms have to deal with this in different ways, right? So the MES handles real-time and structured and actionable data, like order tracking, quality checks, operator inputs, and so on. And it essentially focuses on immediate control and traceability. So essentially, it only stores what's needed to ensure the execution, the compliance, and the reporting. On the other side, data platform, it's built for scalability and analytics. So this is where we ingest high volume, high frequency data from machines and systems, and then of course combining this with MES to provide this level of context that I told you about. And so they're able to do this by the integration. The integration here is the key. So together, MES and the platform divide the workload. The MES filters and records the actionable data for execution, and the data platform captures this high volume, high velocity data for analysis and insight. And it's by working in tandem that they ensure that no valuable data is lost, and each system can do what it does best, ensuring control on the shop floor and enabling continuous improvement through analytics.
Now, I know that a big issue with manufacturing data coming from multiple devices and systems relates to companies, needing to contextualize all of this data for analysis. Can you explain how critical manufacturing uses AI for this?
It's a great question because contextualization is something that I already referred here a couple of times, but we don't use AI to perform the contextualization itself. Instead, we ensure that the data is automatically contextualized, starting at the source, by linking sensor or equipment data with key operational information. I'll give you an example. If you have a temperature reading from a machine, it can be enriched with additional information. For instance, the type of machine it came from. What was that machine? When was that machine going on maintenance the last time? What program is it running? What type of material is being processed, and so on? What's historical uptime and performance of that machine? And this added context then transforms raw data into really valuable information that can be used effectively for monitoring, analysis, or decision making. And once the data is contextualized, this is when AI and machine learning come into play. And so then we use AI to detect patterns, regressions across machines, That's when we train purpose-built machine learning models for specific use cases, and also how we use them. Then the models are deployed within the platform so that they can run automatically in production, analyzing new data in real time, and then, of course, delivering actionable predictions directly into operations. And so this layered approach, first the context and then the intelligence, ensures that AI is applied to data that actually makes sense. Then, of course, at the end, resulting in smarter decisions and having as much as possible a real impact into the shop floor.
Thanks for clarifying that point. I wasn't sure how that worked, that AI isn't involved in contextualizing the data initially. It comes after that it's applied. So thanks for clarifying that point. So how can MES and industrial data platforms, working in tandem and then leveraging AI, be applied to improve production and operational reliability and minimize downtime?
Well, when MES and data platforms work together and are enhanced by AI, they form a really powerful foundation for improving the operational reliability and minimizing downtime, as an example. So the MES ensures consistent execution by managing the production orders, enforcing processes, and so on. And it handles real-time control and traceability. The data platform continuously ingests this high-frequency data from machines, sensors, and systems, and enriches it with MES context. And so the AI and machine learning models are trained on this rich data set to predict potential failures before they occur, to, for instance, identify process deviations or root causes of downtime, to optimize schedules, to optimize settings to avoid, excess stress on equipment. But it goes further. These models can also alert operators or technicians early before a problem is visible. They can provide recommendations or actions, such as, for instance, adjusting a parameter or triggering a planned maintenance activity. Automatically trigger responses like stopping a machine, rerouting production, executing a specific MES transaction. So what I was telling before, and this is exactly to your question and how we can improve operations, that this closes the loop from insight to action, sometimes even autonomously. And the result is really a shift from a reactive to proactive and even autonomous reliability management, reducing unplanned downtime, extending asset life, improving production stability.
So, given what we've discussed so far here today, what advice do you have for manufacturers who are looking to integrate legacy equipment and systems into an MES and industrial data platform framework?
That's a great question, because integrating legacy equipment and systems is one of the most common challenges in modernizing manufacturing environments. But today, it's highly achievable with the right connectivity strategy. So at Critical Manufacturing, we address this through two main different approaches. There's one which is the protocol level integration that we have in our equipment integration layer. So our product in this area is called Connect. It's a solution that allows you to integrate with different equipment using specific communication protocols. So we support a wide range of protocols, and this can be really from high-level specific standards, like, a SecGem in semiconductor, which is a fairly sophisticated communication protocol, to lower level and more modern protocols like MQTT or Bluetooth or some others. And so the idea there is that it is possible to develop custom drivers to interface with equipment that uses proprietary or outdated protocols, and by that enabling integration also between equipment, MES, and data platform. Another approach is an OPC server integration. So it's a common approach, which is to use an OPC server. And so many legacy systems cannot connect directly to modern platforms, but they can expose their data through an OPC interface. And so this makes it accessible to both the MES and data platform in a standardized way. And then the final thing is that even if you have equipment that do not have sensors at all, it is possible today to retrofit with relatively inexpensive sensors to capture data, I don't know, such as vibration or temperature or counting pieces or usage. And this data can then be collected via Connect using one of our supported protocols. And this really makes even the older machines part of a digital ecosystem. So in short, if a machine can produce data, then we can integrate it. And that's basically what we say. So it is possible today to really gather data even from legacy equipment.
Thanks for explaining that, because I know that's, most manufacturing sites are brownfield, so that the issue of integrating legacy equipment and systems is very prevalent, to say the least.
Absolutely.
So can you provide some examples of how manufacturers in specific industries are using MES and industrial data platforms today?
Absolutely. So we have a few examples. So we operate in different segments. I can tell you that, for instance, semiconductor manufacturing, which is one of the main areas where we work. So it's a highly complex and regulated environment. And typically, MES uses to integrate to equipment's XGEM interfaces that I told you about, with tightly controlled production steps, with topics like recipe management and traceability at the wafer level. And so combined with the data platform, they perform, for instance, advanced yield analysis and predictive maintenance to reduce scrap, to reduce downtime, and of course, at the end, leading to higher throughputs and a better first pass yield, which are really competitive factors in the industry. We also work in the medical device space. In here, the MES ensures a very strict regulatory compliance, for instance, FDA related. And their traceability and quality enforcement is some of the most important aspects. So when combined with the platform, manufacturers can analyze process deviations, they can predict potential compliance risks, accelerate root cause investigations, reducing time to resolution, and supporting faster product releases. So, it's possible in each of the segments to find really good use cases that we're working. Just to give you a final example, in automotive and electronics firms that use MES for build-to-order processes, for sequencing and for variant management, while the data platform captures machine and test data for real-time quality analytics and supplier performance monitoring. So this enables just-in-time, high-mix production with fewer disruptions and lower defect rates. So in every case, there's always a combination of precise MES, deep data insights with the platform, and smart decision-making that delivers competitive advantage at the end to the customers.
So I know we touched on this just a moment ago about the integration of legacy equipment and systems, and how that's can be dealt with. But based on your experience working with manufacturers, are there other specific challenges that companies need to be aware of when they're looking to integrate MES with industrial data platforms?
Absolutely. So yes, legacy is one that you have brought up. But from our experience, it's these two systems, the MES and data platform, working together. This is one of the main challenges, especially when you have those separated. One major issue is contextualization. So if the systems don't speak the same language, the teams are forced to manually align timestamps, to write custom queries, and to build really fragile data pipelines just to match machine signals with production context from the MES. And so this is a tedious, error-prone, and difficult to scale process. Another common problem is the lack of a common data model. So if MES and the data platform don't share a structured way of organizing data, you essentially start from scratch, creating mappings, defining relationships, trying to impose order on a stream of disconnected data. And so, there's a notion that simply dumping raw data into a data lake will allow you to generate insights, but it's not like that. And so what happens is that if you don't have this, then companies invest in data engineers, in data scientists, and they often end up spending the majority of their time cleaning data, doing queries, moving data, instead of analyzing it or building models. And this is a huge inefficiency. So it slows down innovation, it delays realization of value. And so, the key takeaway is that real progress only happens when the MES and data platforms are designed to work together with built-in contextualization, with a shared data model that eliminates friction and lets companies and people focusing on really generating insights and not plumbing data.
So finally, Francisco, what advice would you give to manufacturers in terms of how they can best calculate the return on investment involved with implementing MES and industrial data platforms?
Yeah, that's a really interesting one, and I'm glad we finalized with it because, calculating the ROI for MES and an IoT data platform isn't straightforward, and in many ways it should not be treated like a simple business case. After all, for instance, nobody asks for an ROI calculation when they are implementing an ERP. So why is that? Mm-hmm. It's because it is understood to be foundational. It's a critical infrastructure for running the business. And MES and data platforms are the same, just for operations. So that said, of course, it is possible and often useful to calculate ROI based on specific use cases. For example, you can quantify cost savings from reducing unplanned downtime, from improving yield, accelerating root cause analysis. These targeted wins can provide compelling early justification. But it's important to remember that these platforms are not point solutions. So this means that their true value lies in their flexibility. They are designed to solve the problems you have, but also the ones you haven't discovered yet, and the ones you will encounter as your business evolves. And that makes them, in my perspective, strategic investments. They enable faster innovation, more resilience, and long-term competitiveness. So while individual projects can demonstrate ROI, the real return comes from what the platform enables over time, from continuous improvement to scaling new digital capabilities across the operations.
Well, thank you again for joining me for this podcast, Francisco. And thanks, of course, to all of our listeners. And remember, you can find us online at automationworld.com to stay on top of the latest industrial automation technology insights, trends, and news.